Hello students, relax, sit back and listen to our math class. This video is a continuation of cardinality and application of cardinality part. Okay, so first before watching this video, first watch the video and watch this one. The link is given in description. Here, if A and B are two finite set, then first rule is n of A difference B equal to n of A minus n of A intersection B. Here n of B difference A equal to n of B minus n of A intersection B. So first take the first rule. First we can verify this first one. Okay. So take the LHS. N of A difference B. So first find A difference B. A difference B means the elements which will be in A but not in B. So here B is in A but not in B, B comma D comma G. So n of A difference B is that the cardinality of A difference B is 3. Next, take the right hand side. First find the n of A. N of A is 5. Next find n of A intersection B. That is the elements common to both A and B. So here you will write H 2. Next do subtraction. So n of A minus n of A intersection B, 5 minus 2 equal to 3. So LHS equal to RHS. So n of A difference B equal to n of A minus n of A intersection B. Next, we can verify this rule. Now, for verifying this second rule, n of B difference A equal to n of B minus n of A intersection B. So, consider this left hand side and right hand side. First take this, first find the B difference A. So, B difference A means A comma C, because C and H are in A. So n of B difference A is 2. Next, go to RHS. First find the n of B. So the number of elements in B is 4. Next find n of A intersection B. So the common elements of both A and B are, this E and H is common, so 2. N of B minus n of A intersection B. So 4 minus 2 you will get 2. You will get 2. So here LHS equal to RHS, which implies that n of B difference A equal to n of B minus n of A intersection B. Thank you for watching. For more videos related to both school and college maths, kindly subscribe to our channel Curious Maths. Kindly like, share, comment your doubts.